So we have done the basic initialization and the ASA overview. We have seen the IP address assignments on the firewalls, how to do that. We have understood the traffic flow with respect to security levels, with respect to your how the traffic flows from inside to outside or between the security levels, how the things works. So based on that, we have done even static routing and default routing yesterday. So we have seen how to implement those stuff. Based on yesterday's discussion, I mean, we are continuing with the routing topic. So we are going to study implementing routing protocols, and again I expect the prerequisite as you guys to know the routing protocols from your earlier studies. So we would see first of all how to work with RIP. So in terms of routing protocol, when we discuss, we have two classifications, all of you know that. So one comes in IGP and we have RIP. Generally we implement RIP version 2 for classless networks. We have IGRP, EIGRP. IGRP is obsoleted, so we can go with EIGRP. Then we have OSPF and ISIs. So we classify them under IGPs. And likewise, we have one EGP, and the only one beast that we have in EGP is Border Gateway Protocol. And the modern implementation of BGP is BGP version 4. So what we do is, I mean, we learn the implementation of ISIs is generally not used because it has got a different concept while implementing it. So we would see the regular protocol that we implement, RIP, EIGRP since it is Cisco device, and OSPF, and also we'll see BGP implementation. So my focus is not to draw different topologies of different routing protocols and explain you how it behaves. So we are going to implement routing protocol as a solution with your firewall. So it will accept all your routing updates, generate routing updates, all right, and ensure that it can work cooperatively with your surrounding devices that is supporting the same routing protocol. So we talk about RIP. I mean, you know that RIP has got a couple of versions, version 1, version 2. By default, we work with version 2 because it supports classless. It supports we can disable auto summarization, and RIP. By the way, it works with multicast. So can anyone see me the multicast IP address of RIP in case of version 2? All right, ensure that you guys know routing and switching really well. Okay, I mean really well. So multicast IP address 224.0.0.9 is the RIP multicast IP that we have. I mean, I'm not going to discuss here how RIP works and what is the functionality of RIP. I expect you guys to know it. Okay, so behind the scene, if I want to enable RIP on a router, so suppose I want to enable this protocol RIP version 2 on a router, how do I do that? So I'll go to the router's global config mode and I will define router RIP. I will define the version as version 2, right? I will define with no auto summary if I want to ensure that it has to go with classless subnets. And I will ensure that the RIP is going to work on the interfaces based on my network command. So for example, if I take a router and let us say we have got some 3 interfaces where I want to enable RIP, and just imagine this is port 1, port 2, port 3. This is part of 10.11.11.0/24 network. This is part of 10.1.1.0/24 subnet, and so this is part of 192.168.1.0/24 subnet. So we have one classful network over here as 192, and we have got a couple of classless network over here. So in case of RIP, I mean, I hope you guys know these things, that when you talk about RIP and when you say network, you have to give the major address, not the subnet address in case of RIP. So in network command, whatever the networks you define, it should be a classful address, not the classless one. So if I want to run RIP on all the 3 interfaces, I should give network 10.0.0.0 because this is a classful one, which will run RIP process on interface 1 as well as on interface 2. If I try to give, instead of 10.0.0.0, if I try to give 10.11.11.0, what happens is RIP automatically summarizes this back to the classful one, and it runs its process on those interfaces, who is having an IP address from 10. Series, right? So the whole idea is, if you talk RIP, I mean, you should not configure classless network address in the network statement, right? So normally you go with the classful approach. So if I want to enable RIP on all the interfaces over here like that, so what I should do is I should say network 10.0.0.0. So this will ensure RIP to work for both the interface, and one more network command to run RIP on 192.168.1.0 interface, because there is no concept of wildcard mask or subnet mask that you define with the network statement along with RIP. All right, so thinking about this, so ensure that we give this statement, say network. All right, so network 10. Network 192. That's the way you normally RIP on your routers. Very important stuff. The similar way, I mean, you take it to run RIP on the ASA as well, right? So, I mean, there is no difference. There is no difference in the syntax. So either you enable router is a similar way you enable RIP on ASA, right? The most important thing that we are talking about in this discussion, in case of firewall, when you enable any routing services, I mean, the most important thing that your customers or industries would need is authentication. So ensure that you enable authentication between the RIP enabled device. Okay, so we'll talk about authentication in some time. Hold on for that, and we'll see. We'll configure RIP authentication stuff, and how the things goes. So we would actually talk about authentication, but I would actually give you one objective now. So I had some static routes yesterday, right? So I have actually removed those static routes by using a command. So you can use a command which is called as clear configure route. This is a special command in case of ASA. Once you give this command called as clear configure route, is a global config command. What happens is whatever command that starts with the keyword route will be cleared. So if you say route inside, like all the static routing command and the default routing command is configured with this route keyword. So what happens is all the static and default route would be removed. Okay, so ensure that this was done, so that I don't have any static and default route in my topology, right? So what I want to ensure that I run RIP across all the 4 routers over here. So R1, 2, 4, I should run RIP, and on the ASA I should run enable RIP on all the connected interface, and ensure that it is getting all the routing updates using this protocol RIP. So that is my task. Let's say configure RIP version 2 on the topology. Ensure all the LAN networks of R1 to R4 are known to the ASA using RIP. So the RIP protocol must ensure that the ASA should know about all the surrounding networks using this RIP updates. Okay, and one more important task that you normally get in the industry is this, configuring authentication. So you'll be configuring, let's say, configure a clear text authentication. Between the ASA and say one of the DMZ, which is say R3 or R4, say R3, and let us say my password, or normally we say this is key string in case of authentication. Key string used will be say Cisco 321, and we want one more thing, which is an MD5 authentication. So let me just copy that. So configure, because RIP supports both clear text and MD5 between say ASA and the outside router, which is R2, and in that case the key string that I want to use, say it is Cisco 222. So first we need to ensure that we run RIP across all the routers and on the ASA, ensure we get the updates, and then with respective, routers surrounding me, through the ASA, we configure one with clear text and one with MD5 authentication. Now, what is authentication? I think you guys know that already from your previous counterpart. So basically, authentication, it's a process, right, by which you granularly, can control which device can connect through the firewall. And exchange your RIP updates, right? So basically, you are authenticating the routing updates. So whichever two devices, when they exchange the routing updates, ensure that they are using the same password or the same authentication parameters to securely exchange the updates. So if ASA is told to configure authentication with R3, so whatever routing updates RIP is sending towards the ASA, it should be the RIP updates should be authenticated, right? So you use the authentication details called as, two parameters over here. So normally you'll be using something called as a keychain. The way to configure will be like that. We'll use a keychain name, which is like nothing but a placeholder. In the keychain name, you define two parameters over here. One is called as the key ID and the key string, right? So for authentication in case of RIP, both the key ID value and the key string value must match. So between the ASA and the R3, so if ASA wants to receive and also send RIP updates towards R3 with authentication, ensure that both the device has the same key ID and the same key string, basically the password, which has to match. All right. Otherwise, updates won't be exchanged if the password or the key ID is different. So RIP supports two types. One is called as clear text. It is not recommended because anybody can, use a packet analyzer tool and view what is authentication ID, and can attach a ROG device and receive or send RIP updates, which is very harmful in case of routing is considered. So naturally, you don't go with clear text. Naturally, we go with MD5. MD5 is the one. So the authentication characters, when you send to each other, those characters will be hashed using this MD5 algorithm. So ensure that the two devices must have the same MD5 hashes or the same MD5 passwords to decrypt and encrypt the traffic or the authentication data. So I want to configure MD5 authentication between 2 and the ASA, and clear text between the ASA and one of the DMZ R3. That's my goal. All right. So thinking about this, we'll talk about the configuration now. So what we do on the routers. So let's go on the surrounding routers and configure RIP. So let's say I go to R1. I say router RIP. I say version 2. Of course, I have to give the command auto summary because I have all the classless networks over here. If I don't give no auto summary, I will send the classful information as my routing updates. And I ensure that I run RIP. I know what should I do now to ensure to run RIP on all the connected interface over here. What is the network statement I will configure now? So see, if I give 10.1.1.0, right? If I wanted to advertise RIP only on this interface, it is not possible in case of RIP. So if I wanted to enable RIP only on 10.1.1.0, that is not possible with RIP. It is possible with EIGRP, it is possible with OSPF, also with ISIs, because we can be interface specific while advertising a protocol. In case of OSPF, ISIs, EIGRP and all, but not in case of RIP, because RIP by default don't understand or don't have the concept of attaching a wildcard mask or subnet mask along with the network statement, right? So if you define 10.1.1.0, what RIP will do is automatically convert this into 10.0.0.0 as class full and run the process for all the interfaces that is serving an IP from 10. Okay, so look into that. That is the reason I have told it is a waste of time to give classless network statements to RIP. If you give this, what happens now? If I give 10.1.1.0, so if you look into show IP protocols, you will see that RIP is enabled, right? And you can see RIP is enabled for all the interfaces over here, couple of Ethernet ports and couple of loopback, and it automatically summarizes the entry back to what? 10.0.0.0. You get the point. So if you see show run section router and see the routing protocol configuration, you will see though I give 10.1.1.0, it automatically converts back to what? the classful one. Okay. All right. So this is enabled with RIP process on all the connected ports. Similarly, let's go to R2. Run RIP over here. Router RIP version 2. No auto. Network. I have 10 dot. In the loopback, network 199. This is class C, so 199.110, 200.110, and 192.1.20.0. Enable RIP on all the 4 interfaces, 3 loopbacks and Ethernet for R2. If I see here, show IP protocols, I can see which all interfaces are participating for RIP. So I can see 3 loopbacks, and the Ethernet port is running with RIP version 2 over here. Similarly, we go to R3 and 4, enable RIP, router RIP, version 2, no auto summary, network 10 dot for the loopback, and network 192.168.3.0 here. I see do show IP protocols, and I can see it is enabled for Ethernet and the loopback interface. Last but not the least is R4 in terms of routers. Router RIP, V2, no auto, 10 dot, and 192.168.4 dot. Done with that, do show IP protocols. You can see it is also running for the Ethernet 0 and the loopback interface. Now, we enable RIP on all the surrounding routers. So at this point of time, can R1 learn the RIP updates of other routers? Can I go to R1 and see the RIP updates coming here? It will not run. So what is happening is behind the scene, what is happening is those routers are talking RIP now. If you do run a command called as debug IP RIP, you can see that the RIP updates are going from this routers all the way to the firewall, right? It is coming up. So all the RIP updates are going to the firewall, but since on this interfaces of the firewall, the RIP process is not yet enabled, it is getting discarded, right? So how do you enable this RIP service or the RIP process on the firewall? Same stuff. When you go to the ASA and say, network statement inside RIP and run this network, it runs the process on G0/2. Network 4.0, it runs the process on G0/1. So to enable the RIP on per interface basis, you define the network statement, and based on that, it gets enabled per interface. So we go to ASA now, right, and make sure that if, let us say, we had a static route yesterday, so you can give this global config command called as clear configure route. Okay, so when you give the command clear configure route, what happens is, as I've told you in the notes, all types of static route configuration, if you have done some configurations, they will be removed. Okay, so now let's go with RIP. So we go with router RIP version 2, no auto here, same statements. Network, I want to enable RIP on all the connected networks. So with outside it is 20.0. With DMZs it is 192.168.3.0, 4.0, and we cannot give here 10.11.11.0. We have to give 10.0.0.0. We can give, but it is of no use. Ensure that what I'm trying to say. Okay, done with this. So now what happens if you see show IP protocols or show protocols or show processes? One second. Show run router, if you do, that's the best way. So when you say show run router, you can see the RIP is enabled, and you can see it is enabled for all those networks. And right now, if you look for the routing updates, if I see show IP route, so I'm on the ASA and I'm trying to view the routing update. So on the ASA, I should learn all the remote networks that is coming through RIP. So I'll run 10.4, 10.3, all the LAN corp info, that is 10.1, 10, 10, 10, 20, and also this outside networks. So if I look here, sorry, show IP route is not used here, show route. And you can see you have got the connected routes along with the RIP routes, right? just want to specify RIP, so show route RIP, and you can see you have learned all the respective RIP routes, 10.1, 10.2. You don't see with the CIDR value, normally it appears like with a subnet mask, the outside networks, right, and also the DMZ networks, everything. And everything is reachable with an AD value of 120, that is default with Cisco implementation of RIP, and the hop count, which is the metric used by RIP, is 1 hop for all the networks to reach. And the respective, next hops are listed with your port IDs. Now, so from the ASA right now, we know all the routes, right? So from the ASA, answer me these things. From the ASA, can I go and ping 10.2.2.2, just outside loopback? And routing is not the problem over here. Sorry, it is 10.2.2.1. One second. The loopback IP is 10.2.2.1. And similarly, I can ping 199. I can ping everything, 200, 111. Even I can reach the DMZs, which is 10.333. I can reach 10.444. And also I can reach the inside network from the ASA, which is 10.10.10.1, 10.1.1.1. From the ASA, everything is reachable right now. Routing is not a concern. And you can reach, means ICMP is a default service that is allowed as a 2 traffic on the interfaces, which we discussed yesterday, and because of which the surrounding pings are working. All right, now look into the concern over here. If I go to R1, will R1 learn about, all the routing updates?
Yes.
So if I go to R1, you should learn the RIP update. So for example, the ASA has learned this networks using RIP, right? And make sure that it is ASA's responsibility to form or forward the RIP updates to the other routers. So what happens by default is, don't think that R1 updates are going to R3 or R3 updates are going to, going to R1, transparently. What is happening is this updates of RIP when it comes to the ASA. So this becomes, one segment of RIP, and ASA would initiate the RIP updates from his end towards R3 or towards R2 or towards R4, right? So that is the reason the next hop will not be, the router's R1's IP address. So for example, if R3 has to reach 10.1 and 10.10 network, the next hop should be the ASA's IP address. So because of which, it gets the update in one segment and throws the update from the other segment with this IP. All right, so if you look into, let us say, R1, you will see all the routing updates over here. Show IP route RIP, and I can see I have learned everything. So you can see that you have the outside networks 10.2, 199, 200, the DMZs 10.3, 10.4, and also the links surrounding them. And to reach every network, so what is the next hop? The next hop is your firewall IP, right? The next hop is your firewall IP address. Likewise, if you go to outside, say R2, same stuff, show IP route RIP, you'll find the next hop is always the firewall IP to reach anything, your inside, your DMZ, whatever. All right, so answer me this now. So if I go to R1, so from R1, can I ping the DMZ or can I ping the outside? So from R1, if I try to reach, let us say 199, 111, is that possible? I can ping from R1 to this IP address of outside. The logic is all about routing. So, the RIP has advertised the route, that's it. The ASA knows about the routes, that's fine. But can they ping? Ping is a through traffic, right? It is going from security level. Inside to outside traffic will go, but the reply won't come back, right? So for ICMP, this is the concern. So similarly, if I go to R3, from R3, can I reach outside? Can I reach with ping? Basically, I'm trying to send ICMP packets from R3 to outside, going from high security level to low security level. ICMP is not allowed. The traffic can go, but the return traffic won't be allowed because for that I don't have a connection table. Clear? So I have the route in the routing table. Routing is not a concern here, careful. See, it is known to me as a RIP route. That's fine. But having a route does not mean that you can ping. Okay? That's a beautiful thing, and that is the most important thing that you should be worried about when you talk about firewalls. Similarly, ping, let us say 199.111 from R4, even that is not going to work because ICMP return traffic is not allowed. But what will be allowed? I mean, from inside to outside, if I want to go using HTTP, HTTPS, will that work fine? Will Telnet and all, will that work fine? Can I say Telnet 199.111? The TCP traffic, inside to outside, high to low, connection table will be there. I'll have the return traffic from the connection table allowed back. Not going back and discussing this, right? Show users, this is happening. And I'll have a connection table on the firewall. I've shown these things yesterday very specifically. Show con, you can see the connection table is there, allowing the traffic from outside to inside with the reflexive port numbers. Right, so this is working fine. I mean, everything will work fine apart from non-TCP, non-UDP packets will never work. Apart from that, everything else will be working fine. So the next thing that you have to understand is what? Is your authentication. So how do you enable authentication? So I've told you in the context to run authentication between, clear text authentication between R3 and the ASA, right? You need to configure authentication between R3 and ASA. So if I go to R3 and try to enable authentication for RIP, how to configure RIP authentication? Basically clear text. So I go to the interface. Normally authentication is always per interface concept, right? It is always works by per interface basis. So you go to the router interface. I want to configure clear text between R3 and the ASA. So I'm on R3. I am inside interface E00. I give the command called as IPRIP authentication mode text. When I define it, so I'm enabling clear text authentication, and then I give a command called as IPRIP authentication keychain. Let us say the keychain name is, just imagine the keychain name is ABCD. Let's keep it normal. So what I've done is I went to the port. I told it, hey, you are RIP enable interface. So you're running with an authentication with clear text mode, and your keychain is basically this with a keychain name. So now my job is to configure keychain, right? So in the keychain, that is my placeholder, which name is ABCD. I have to go and configure the key ID. So key ID is 1, and I have to configure in the key ID a key string, which is according to my objective. The key string is basically the password, which is Cisco 321 for clear text. For Cisco 321. Good. So what I've done is I've applied this particular keychain into the interface, and this keychain is holding this key ID and this key string. So ensure that the same information I should have for authentication where? Also on my ASA. All right. So what I do on the ASA here? So on the ASA, I have to go to the respective interface connecting R3, which is G0/3, and I have to go and say what? RIP authentication, mode is text, RIP authentication. You can directly define. So there is no need to configure, the keychain and all those things. We can directly define the key string parameter per interface. So what is the key string parameter over here? Cisco 321, and the key ID which I have, it is key ID as 1, because both the key ID and the key string must match port level. Right? Once you define, then only your routing updates would happen. So if you go to R3 now, if you see show IP route RIP, you see the timer over here. You just learned the routing update. Just on the routing update, because once authentication was done, you would have went to the hold down timer, right? And you have learned the recent update right now. So similarly, if I tell you to configure authentication as MD5 between the ASA and R2, similar process. So we'll go to R2. It's again for interface basis. So you can define on the interface, which is E00, you can say IP rip authentication mode as MD5, and you can say IP rip authentication, say keychain, say whatever here, say PQR, okay, whatever name I gave here. So whenever authentication keychain name is PQR on the interface E00 of R2, but I should ensure that my keychain PQR is created. So keychain PQR, in that I should have a key ID, say key ID1, and key string which I wanted as per my objective, it should be Cisco 222. Key string is Cisco 222. So enable keychain key string on this particular interface of R2. The same stuff I should have it on the ASA as well. So on the ASA I should go to the respective interface, which is G0/2 in our case, and I should give the command rip authentication mode as MD5, rip authentication key, which is Cisco 222 with a key underscore ID of 1. Once you do that, if you go back to R2, show IP route rip, you would be getting the rip updates, right, with authentication. If you want to run debug, you can run a debug and you can see that you are getting the updates using authentication. So that's fine, that I'm not running it. So basically this is the way to do that. So for you, just to remember this, for this, what I've done is on R3, I went there and I defined keychain, which is say ABCD. The key ID was 1, and I defined key string, which is Cisco 321. And then I went to the interface and I said IP rip authentication mode as text, and then I say IP rip authentication keychain as ABC. On the ASA, what do you do? On the ASA, what do you do? You go to the interface. What was that? G03. So you go to the interface G0/3. You give the command rip authentication mode as text, rip authentication key as Cisco 321, key underscore ID 1. This is the way normally configured. And for the other one, which is between the ASA and R2 with MD5, so I went to R2, I defined the keychain name as PQR, key ID 1, this was Cisco 222, and instead of more text, it was MD5, and the keychain name is PQR. And on the ASA, what we did is very similar stuff. Which is say G0/2, I believe. Yeah. This mode will be, what was the mode? MD5. And what is the password? 222, key ID of 1. Is that point clear to everybody? Yes, no? All right. Now if I want